Edge features Associated Electric's Roger Curtis and Gene Husting, the designers of the RC10. And from Reedy Motors, Mike Reedy. Also, world-class mechanic Jim Halsey shows you modifications to improve your car's performance. And finally, meet the world champion driver Jammin, who gives you the winning edge on racing.
When we decided to get into off-road and design the RC10, we felt we had to do some experimenting first. So we looked at the cars that were available at that time to see what we can improve upon, and then we also looked at full-scale full-scale off-road cars, and talked to some of the people in that business. I looked at a lot of cars at that time and came up with ideas based on those experiences. And as I said, we had a lot of experience from 8th scale cars and 12th scale. So from that point, then we started to build experimental cars. This is one of the first ones. It was nothing like an RC10, but it allowed us to test shocks. In this case, we thought we might be able to use a shock that we already had. This is the shock from the RC500, and this car essentially showed us that, first of all, the shocks were very important, and secondly, that a small shock like the one on the 500 wasn't adequate for the job. So this was number one here. Well, this is my car. It was one of the about 6 prototypes that we built when we finally had achieved a design that we were pretty comfortable with. I ran this car at the New Jersey Off-Road Nationals. That was the first Nationals for off-road cars. That was sponsored by Roar, and I did pretty well with this. For a guy who hasn't raced for a long time, I was in the A main and did very well. Of course, we had a big advantage because there was only 6 of these cars there. This car looks a lot like the RC10. It's basically like the finished product, except that a lot of these parts are handmade. Chassis, for instance, is made by hand. It doesn't, you wouldn't believe it, but it's been hammered over a mold, and if you got up really close, you'd see some of the dents. This is one of our first production parts down here. That was the front A-arm. That was molded. That's a handmade part there. These inner mounts here, suspension mounts, are handmade. Of course, all the fiberglass stuff was cut out by hand. This car, I ran this car for probably 2 years or so. After that, I don't think I changed a part on it. So we were pretty confident after doing that we had a car that would be rugged. Well, this is the final product. This is what you get when you buy an RC10. Pretty close to the final product. It has a chrome or metallized wheels. The actual car doesn't have those. I think this is pretty much a stock car. We use all engineering, what they call engineering materials in the RC10, which means materials that are the highest strength to weight ratio that's available. Kind of things they use in aircraft and so on. So the chassis is made out of aircraft aluminum. It's 6061 T6 aluminum. Dog bones in the back of the car. It's the way that the power is transferred from the transmission to the rear wheels, and it allows that power to be transferred without interfering with the suspension action. We have a special machine that makes dog bones in about 1 every 30 seconds. Well, when I designed the car, I drew 2 lines on the paper. One line was the ground, and then the other line, about an inch and a half above it was the bottom of the chassis. And the intention was to make a car that had plenty of clearance under it and would have the ability to travel over a really rough terrain. So if you look at the RC10, it's very clean underneath. There's nothing hanging down below that line that I drew on the paper. In keeping with the idea of having a lot of clearance under the car, it meant that the transmission had to transfer the power out at a very low position on the chassis, because if the transmission had its output shafts up high, then the dog bones would have to angle down far too much. So this transmission was designed to have output shafts right on the chassis level, and that allowed the dog bones to be level when the car is sitting on the ground. And when the dog bones are level, then you get the maximum efficiency of power transfer between the transmission and the wheels. Well, we tried to make the suspension adjustable, and it's probably more adjustable than most people realize. There are things on here that we haven't even explored ourselves. The upper arm in the front end is, of course, adjustable in length, which allows you to change the static camber. So if you shorten this arm, the wheel would tilt this way, and if you lengthen it, it would tilt that way. You have to make that adjustment when you're on the track to determine the tire wear and get the car to handle correctly. But you can also adjust the roll center of the car, and that would be achieved by moving this inner pivot on the upper arm. It can be moved into any of these hold positions. The position it's in right now is in and up. That would be what you would call a parallel A-arm suspension, and in that position the roll center is near the ground. You can also move this pivot point all the way down and out to where it's on the outer hole in here. That would make the rear suspension have a higher roll center, more like a swing axle suspension. If I'm out trying to have fun racing, I don't really spend a lot of time maintaining the car. It's not necessary. The car is perfectly capable of running for a long time without doing anything to maintain it. If I'm serious about racing, then I'm going to spend more time on it. Every heat, I'm going to take a look at the car. I'd probably get in and change the grease in the differential each time, look the car over to make sure there are no loose screws, and check the action of the suspension. It's really very important that the suspension be able to move freely up and down, and sometimes that's hard to see. It may feel okay with the spring and the shock on there, but if you took this and disconnected the shock down here and moved the suspension arm without the spring on it, you might find that it was binding a little bit. You should be able to lift this up and have it drop all the way down freely and have it not bind at all. You can learn a lot by just dropping the car. If you watch it after it hits the ground, the chassis goes down and then it comes up and comes to a stop. And that's when the oil is correct and matches the stiffness of the springs. But if the oil is too light, then when you drop it, the chassis is going to go up and down several times. You'll see an oscillation in there, and that would be as if you had no shocks at all. And if the oil is too heavy, when you drop it, the chassis is not going to go down as far, but you'll see the tires start to bounce. It'll do something kind of like that. You'll get a lot of bouncing action in the rubber itself. The purpose of the differential is to allow the rear wheels to rotate more or less independently of each other. So if you take the car and go like this, you'll see that one rear wheel is moving one direction, the other one's moving the other way. On the track, the car is turning most of the time. You're making a right turn or a left turn, and the two rear wheels really can't be turning at the same speed when that's happening.
We also went and looked at real off-road cars to see what their problems were, and we asked them about their suspension and why they did the things the way they did, so that when we designed our car that we'd have an idea basically what we wanted to try. Well, we tried a lot of things, and I can tell you not everything goes right. I mean, we built I think 6 different prototypes before we got to the RC10, and but it was a learning process that taught us a lot. And so by the time we got to the RC10, we pretty well knew what we wanted to do, and then it was just kind of designing the ideas that we had learned before into the basic car. And Roger Curtis designed, I'd say, at least 90% of the car. He gets the credit for the car. There's just no doubt. I mean, my part was rather small. I did the wheels, and I did the basic body tooling and wings and stuff like that, which did out of necessity because we were running out of time, and things like that had to get done, you know. Today, looking in the future, I know that it's still growing, and it is a sport that I think every kid has to feel that he's a driver. I mean, it's one of the normal things about growing up is that you just know that you're born to be a driver. And this is a way to find out without killing yourself, without, you know, bankrolling your house, and to do it like basically when I started with real cars, you can do it, and you can. It's a family sport too. There's a lot of ladies that drive. There's a lot of kids with their fathers that can drive. So it's something really that a family can do together. What I would do would be to go to a local hobby shop. They're going to have off-road cars. I mean, it's something that's in every hobby shop now, and they can tell you where the activity is in the area. Say they're running over on 1st and Main Street or whatever. They can tell you where people are running, and then when you get to where that is, then it's easy, because then you can get more help. You can actually see the cars run. In the off-road kind of racing, right now we have what would be 4 classes. We have a 2-wheel drive class, which is divided into a stock motor class and a modified motor class. And then we have 4-wheel drive class, which is also divided into a stock motor class and a modified motor class. In the beginning, we had the 2-wheel drives and 4-wheel drives raced together, but our RC10 was good enough in the beginning that it was beating the 4-wheel drive cars. So it was a natural progression to change to a separate 4-wheel drive class. And so now we have the 4 separate classes that don't race together anymore.
Beginner, I would say to go out to a few races, talk to some of the racers, take your car with you, let them show you things and try and help you, and then get a little practice. Go out to the racetrack and just run and get familiar with your car before you enter your first race. Most of the motors in the United States right now that are used for racing originate out of Japan. I modify them to get more speed, and the modifications are that we rewind them to get a little bit hotter motor, faster motor. We also install ball bearings to reduce the drag and get a little bit more speed, and mainly blueprint, fine-tune the motor to make it run at its maximum speed and requiring less power. And then I make modified motors for all the various sizes, and they become specialized in that we make a motor for a road course, and we also make a faster motor for the oval racing. Car makes a big difference. Without a good running car, you can't have a good running motor.
For this race to fight.
Halsey, world-class mechanic, shows you performance modifications for your RC10.
Jay and I prefer to run our batteries front to back. And with the RC10 you have an option of running your batteries from side to side or front to back. In the front to back position, we prefer to run the gold springs that come with the kit. We feel that it makes the car more responsive and controllable. We have found, however, in our experience, that when we run the batteries from side to side, that the silver springs handle much better on the car with the batteries in that position. The other thing is that we use entirely stock parts in the shocks. What I found works best for our particular suspension setup is trying to maintain the rear arms in a neutral position when the batteries, the motor, and everything is in the car and the car is sitting on the ground. The other thing that I have found is the suspension being located in the center hole for your upper trailing link allows the tire to move up and down and stay in a relatively straight position so that you keep as much tire contact as possible at all times with the surface. On the rear shocks, the position that I prefer is in the outside hole on the lower control arm. We have moved the upper hole in approximately 1/8 of an inch, and it seems to give it a little more progressive spring rate. Depending upon the outside temperature, that's what we use to gauge the viscosity of oil that we run. Many times we find that for an all-purpose oil, normally 30 weight will meet most of your requirements. In 40-degree weather, we have ran 15 weight oil, and in 90-degree weather, we run 40 weight oil. And the only real way to tell that is by actually running the car and seeing how well the wheels respond to the terrain and stay in contact with the actual surface. You want to make sure that the car is not bouncing around, as I look for. I always try to keep as much tire contact as possible with the ground at all times. The other thing that I look for is how well the car is jumping. Many times that will determine the weight of oil. If the car is jumping perhaps a little bit nose-high position, by increasing the rear dampening slightly, many times it will bring the front of the car down. But the car can respond differently depending upon the ride height of the springs themselves. We have found that by lowering the front shock 1/4 of an inch, we're able to give a longer travel. It gives considerably more steering because the tires are staying in contact with the ground when you're going through the rougher terrain. I found it important to deburr every gear inside of the transmission. When I look under a magnifying glass, many times I will find that each tooth has a slight burr, and it's usually towards the outside edge of the tooth. And by taking a file and filing each side of that tooth all the way around the gear, it will drastically reduce the drag inside of the transmission. When a transmission is perfect, it will actually freewheel for 30 to 45 seconds if you're spinning the spur gear with no pinion gear on the motor. Many times I find that when assembling the transmission, the gears that go, the plastic gears that go on the idler and the output drive gears that go on the spine plate many times are too close. So by taking a file and slightly oblonging the hole on the bottom and relocating that hole approximately 15 to 20 thousandths lower, it enables the gears to rotate freely and eliminates the bind. This does not always occur, however, I have personally found it in some of the transmissions that we have put together for Jay's car. I also found that by making sure that the felt seals that are in the edge of the transmission output drives are lubricated with some type of a light oil or WD-40, that it helps decrease the drag and it'll keep the dirt out of the transmission. The other objective of the transmission is to have the diff work as freely as possible. And what I have found is that by drilling the diff and putting a 440 set screw and slotting the washer so that the washer actually locks into the outside and inside aluminum hubs, I've been able to decrease the tension on the diff spring to allow the diff to work freer, which allows the car to turn better, and at the same time it's locked up when you're accelerating in a forward motion. We have drilled lightning holes around the motor mount to reduce the weight. We made sure at the time that we drilled the holes that we did not drill through in order to eliminate any dirt coming through the backside of the gear cover. We've also cut a slight angle on the edge of the rear motor mount to reduce the weight of the car. For normal purposes, we have not done this previously. However, during the World Championships and other very major races, we wanted to get the weight as low as possible and maintain the 3.5 pound weight limit. We run Reedy modified motors, and we make no modifications to the motor itself. The only thing that we do is perhaps change the gearing on the car. Obviously, the longer the run time, the lower the pinion that we have to run. We like to run the Reedy Silver Dot motor for off-road, and it's very mild, comes on very smoothly out of the turns, but still has good acceleration on the top end. And I usually gear it with a 13-tooth pinion and a 54-tooth spur gear. Usually a 1 or 2 tooth change on the pinion gear will drastically change the run time. So our purposes for racing are, if we're trying to get the most out of the motor in 4 minutes, then we gear the motor to have a little cushion so it will run approximately 4.5 minutes under hard conditions. A modified motor, you can adjust the timing. However, we leave the timing set the way it comes from the factory. I found that in increasing the timing, it also increases the amount of radio interference, and it usually decreases the bottom end torque of the motor. And so for our particular purposes, we rely on the motor the way it comes from the factory, and we found that the timing is normally set in the best possible position in order to get the maximum efficiency out of the motor. On this particular chassis, we have milled out the chassis to reduce the weight on the inside slightly. However, we wanted to still keep the strength by leaving some bars down the center line of the chassis. We've also cut the edge of the pan down about 1/4 of an inch all the way around, and then tapered it up so we'd still keep the rigidity between the front end and where the bars attach on the front part of the chassis. We've done this in order to get the weight of the car down to the 3.5 pound weight minimum, and as you can see, we went a little bit overboard, so we had to add a little bit additional weight. The only modification on the rear of the car is that we have cut the corner off very slightly. It's important to keep as much strength in this area as possible. Many times you'll take a hit in the rear end, or the car will actually come down and land on the rear end when coming off of a jump. And so I have found that it's best not to take too much material off in the rear section here, as it seems to really weaken the chassis. The Holiday buggy tire has a better compound than most tires on the market. It is more of a rubbery tire, and I believe, at least in my opinion, I believe that's why this tire seems to work so well. I think it's a combination of the compound and the tread design on the tire itself. I've tried many other tread designs and tire compounds which have more plastic in the tire than rubber, and they just do not seem to adhere as well to the track surfaces. There is another tire on the market that is very similar to this that is put out by Parma, which is also a very good tire, and a little bit different compound, a little softer tire, and then under certain track conditions it works equally as well. For the front, for our purposes, we have always used the Proline knobby tire. It mounts on the stock associated rim, and we found that this meets our needs under all track conditions. We've tried various tires. Most other tires seem to push too much going into the turns under high speed. The knobs on this particular tire allow the tire to actually dig into the surface much the same as the rear does, and I think that is the benefit of the tire. Plus the knobs wrap around on the outside edge, so even when the surface is somewhat soft, you're always getting that traction when you're going into a turn. We found that Sanyo batteries meet our racing needs. Many of the racers have various ways of designing the battery packs, and for our particular purpose we've put the 7th cell off to one side of the pack to keep the weight distribution as low as possible when sitting in the car. The other thing that I always try to do is discharge the batteries overnight and to only run them one time for each race. That enables me to get the maximum efficiency out of the batteries. I maintain a separate battery pack for practicing so that the life expectancy of the battery will be increased by only using it once at each race meet. We use the Novak speed control, which has adjustable brake and variable speed so that you can set it to suit your driving needs. It has two plugs, one that plugs into the power pack of the batteries, and the other plug plugs into the motors. We use a 4-channel Futaba receiver. The important thing is to try to keep the antenna wire as long as possible and to avoid coiling it up over each other so that you do not change the wavelengths or the frequency. We also use the Futaba S131 servo because of the strength and torque of the servo itself. It's waterproof, ball bearing, has brass gears, and it has a very high amount of torque that enables it to center the steering on the car. I'm virtually taking mental notes during the entire race, watching how the car comes off the jump, watching how it goes into the corner, out of the turn, and watching the speed of the car on the straightaway. I find that many times if the car isn't jumping properly, it could mean just making a slight adjustment on the rear wing angle, or perhaps it will mean changing the dampening in the rear shocks or the front shocks. How that's determined is going to be based upon the angle of the car coming off the jump. Also, in the turns, I found that when the car is hooking coming out of the turn, many times if a little more preload is put on the right front shock, it'll have a tendency to make the car push, and therefore it'll take away some of the tendency for the car to hook. But I'm virtually watching every movement of the car, trying to see how I can make improvements on the suspension. The only way that you can actually make those improvements is going to be based upon the reaction of the car, because the improvements have to be based upon that.
Next, world champion driver Jammin tells you about the winning edge and his techniques for racing.
Sometime in the morning, I look, but you're not there. It made me think that I was losing you. You didn't really care. You were gone.
it's lagging out of the corners, if we need to gear up, if we need more top end, how the battery life is at the end of the race, and different things like that. My dad, his part of the team is mainly the suspension. When something breaks, he's basically my mechanic. When we're at the track, when we're at home, we work together. And my part of the team is try to drive as good as I can. I think the winning edge for me is to try to maintain my equipment, have a positive mind when I go into the race, always think positive, and to have the best equipment that I can afford. The most important thing I can say for a beginning racer is to think positive, maintain your car as best as possible, always have a good attitude, watch your mouth on the driver's stand, and looking for sponsors to keep your car always in tip-top condition, keep it clean, drive the best possible. Don't try to go out on the track and drive fast like you see other guys doing. Go out on the track and try to drive smooth. That's the main key, is to be smooth and consistent. My strategy at the starting line is listening for the horn, the very first thing on my mind. Taking off of the line is the second thing, trying to get a very clean start, as clean as started as possible, and reacting to any problems I have on the start with other cars cutting across the track in front of me or coming up behind me, faster cars, and just trying to stay clean on the start of the race and get into the first corner as fast as possible and in front of as many cars as possible, so I don't have to pass them later on in the race and risk taking myself out in them. During the race, there's different strategies I use. If I'm far back at the beginning of the race, depending on what kind of track it is, if I have the car geared so to just make the time or different things like that. If I'm back at the beginning of the race and I get a real bad start, I'll push as hard as I can for the whole race if I'm a long ways back. If I'm not too far back, I'll push, but I'll drive smooth and I'll take it easy on the car, so I'll have battery life at the end, and try to have more motor and battery life at the end so I can pass them then. I have to go out on the track before the race knowing ahead of time what I want to do, what I'm going to do in this corner, the fast lines. A lot of times I'll go out on the track and I'll find a fast line, and I know it's a quick line, but I won't run that line in all the heat races because then all the other people see that line too. So then I'll wait till the main event and I'll use that line, and I can make up time, and all the other racers a lot of times won't know about that line. And I concentrate on the car. I try not to think about anything else, and I try to drive about 5 feet in front of my car so I know what's coming up on the track. When I go into a corner, I turn the front wheels and the car keeps on going straight or it doesn't react right away. Usually that means that I have the wrong front tires on, I need more bite up front, or I need to loosen the front suspension. I compensate to get rid of hooking or spinning out by running less tire or stiffening up the front springs. If I'm in the lead, my main strategy is I try to save the car, squeeze coming out of the corners, use my head when I come up on lapping traffic, and basically just try to keep the car in one piece. Or if it's just a few seconds to go and I'm behind in the race and I have to make up a lot of ground, I have to push really hard, but I have to use my head and go fast in the right places without risking
risking damaging the car or flipping or losing more ground to the leader. At the very end of the race is probably the most difficult part of the race for me. I get very nervous if I'm in the lead. I'm really trying to be careful to save the car, and sometimes I'm too careful and I slow down too much and I can be fast. So the most exciting thing for me is the competition and winning major races, doing my best and coming out ahead of everybody else winning. Not that I win all the time, but when I do, it's a big thrill. It's the only car that was designed for racing. Most of the cars on the market right now were designed for fun or to look realistic. The RC10 was designed to look realistic, but it was designed for racing too. It's a real strong car. I heard that there's going to be a world championship race. I raced as much as possible a year before that. I was hitting all the races, racing 3-4 times a week, getting in as much practice as I could at home. And then I went to the regionals and different qualifying races, but they have, well, you have to either place in the A main or win the A main at certain regionals or nationals so you could qualify to race in the World Championship. And then I did good at the qualifiers and I qualified for the World Championships. If I was racing the World Championships, the main thing going through my mind is trying to blank everything else, trying to take it like any other race, trying not to get nervous, trying to think ahead of time what other drivers are going to do in that race, and to have our equipment dialed in as best as possible. The main thing is we pay more attention to details, little details, to make the car go faster than the average racer would or a beginning racer would. We just make sure everything's nice and free. We test our motors, make sure we got the gearing right, make sure there's no drag in the car whatsoever. I think if you put your mind to it, you can do anything you want. As long as you think positive, you can do it.